So this question is from Rotational Dynamics 2026, JEE 2026, memory based question, and I keep this question in hard category. So what this question says, we have a big disk of radius r and there are two small disks, each of radius r by 50, and this is rotating in this direction with 2 omega and this disk is rotating in the opposite direction with omega. So we have been asked how much time these two disks will take to meet again. So let us say this also it is given in the question delta phi, and one approximation is given that sine delta phi is approximately delta phi, which means this angle is very small. So let me just explain you a small theory over here. So let us say here I will consider this center to center, okay, and let's say after some time this is rotated and it is somewhere here. So the center of this disc comes here. So I will just take this length, okay. So no slipping, that means the r rotated will be same. So I will consider this radius is r and this radius is r by 50. So if there is no slipping, then the arc length should be same. So if the arc length should be same, that means let us say this angle is theta. That means this angle is, let us call theta dash. Alright. So here let us equate the arc length, that is r theta should be equal to r by 50 theta dash, which clearly gives the value of theta dash as 50 theta. Okay. But that is not the task here. The question is a bit more. You can see here. So when this rotates this much, how much angle it has been rotated? So let us join this like this. So this is actually one single line. Alright. So this is theta. That means this is also theta. If this is theta dash, that means this is also theta dash. Correct. So total angle rotated will be theta plus theta dash. Theta plus theta dash, which comes out to be theta. I will keep as it is theta plus theta dash is 50 theta. So that comes out to be 51 theta. Alright. So if this rotates by an angle theta, then this will rotate by an angle 51 theta. Alright. So now there are two disks in the question. So this is the, let me draw another figure. So this is the bigger disk and we have two small disks, right? So this angle is given delta phi. So when this is rotating with omega and this is rotating with 2 omega, if I sit here and observe this disk, so this is rotating with 3 omega. So the relative velocity will be 3 omega, correct? So now time will be the angle rotated, total angle divided by relative speed, that is 3 omega. So how much angle is rotated here? If this initial gap was not there, 2 pi angle, but there is a delta phi initially. So my answer will be theta is how much? 2 pi minus delta phi divided by 3 omega. Now how to find this delta phi? So let us find the delta phi. So here we have, this is capital R, this is R by 50, correct? So I will draw a perpendicular here. So this angle becomes delta phi by 2 and this will be R by 50, correct? So from here sine delta phi by 2 will become how much? Sine delta phi by 2 will be opposite by hypotenuse, that is R by 50 divided by R by 50 plus R, which gives me approximately, yeah, exactly it gives me 1 by 51. So it is given in the question that sine theta is equal to theta. So this becomes delta phi by 2. So delta phi is 2 by 51. So eventually my answer will be from here 2 pi minus delta phi, 2 pi minus delta phi divided by 3 omega, that is 2 pi minus delta phi was how much? We calculated, that is 2 by 51. So 2 by 51 divided by 3 omega. So let's match this with the options. So it goes with option number A. Okay. comes out to be 51 times 2 pi minus 2 by 51 into 1 by 3 omega. So thank you for the video. Please like, share, subscribe for the more solutions.